And that was Jupiter from Gustav Holst. And this is, next up is a traditional Ukrainian dance. And next up we have I Surrender by Matt Coker. I surrender. Now I have an Irish tree. Sleep Soon in the Morning by Kim Robertson.
That was really lovely, Kim. Kim, we're almost at 7:30. Thank you so much.
Welcome.
As usual, we really appreciate it.
Thank you so much for having me.
We were all doing a Zoom applaud, right? And thank you for starting out with Jupiter. It's always fun to have that.
I really thought I saw the wonderful picture of the Jupiter for the topic for the meeting tonight, so I have to take out Jupiter.
Well, thank you again. And I guess it is time to, or almost time, to start welcoming everybody to the meeting tonight. Welcome to the March meeting of Orange County Astronomers. Can you believe we are almost a third of the way through, or quarter of the way through, I guess, 2022 already. And tomorrow, in case people haven't remembered yet, is daylight saving time starts, which is going to make next week kind of chaotic. So please remember to, if you have to turn your clocks back manually, or forward manually rather, spring forward, please remember to do that so you don't get confused come Monday morning, or for anything you might have to go to on Sunday, for that matter. Anyway, in case you do not remember who your officers and so on are, I am Barbara Toy. I have the privilege to be your current president. I really appreciate that. And I think that it is about time to turn it over to our announcement crew. Kyle isn't available tonight. So Ceci is going to be taking over in his place. And Ceci, if you'd like to take it away.
Hey, thank you so much, Barbara. Hello, everyone. Welcome to our meeting. Yeah, it's March. Can you believe it? I tell you. Okay, so we are starting. Okay, so March meeting. Oops, eventually. Okay. Can you see my
Ceci,
slideshow?
we have it the opposite way.
It went to my other screen. Let me unplug my screen. I did perfect in the practice. Oh my gosh, I froze. Oh my gosh, it is all better. Okay, I had two screens going on here,
great.
guys. Okay, so Paloma, take it away.
Hello, all these fantastic new members. We are so pleased that you're here today. We thank you for all your support and for joining us in this amazing adventure. That's it.
Big girl. I know, getting older kids, right? All right, so star party still on hold. You know, we see what's going on. We had a meeting, the board meeting that we were thinking of having one maybe in July. We'll give you more updates when it comes to that time. The astrophysics is finally getting back together. So you've been waiting forever. March 18th at 7:30. Contact Mark for more info. Mask required. Astro imagers are still working on that. It's to be determined. And the beginner's class is every first Friday of the month online with Steve. No, David.
Ceci, before you leave the star parties,
yeah,
just a clarification. We are tentatively planning to have our standard, what we used to have regularly every year, Starbecue in July, and to restart the formal star parties at ANZA as a Memorial Day weekend. And we'll be putting up formal announcements about that as well. Just wanted to clarify the dates.
Thank you. Trustees and Barbara, you just met her. Wonderful, Ressa, and our team. Outreach. So we had an event this week on Friday, and Eric, I know you're here, so thank you for showing up. We are working on getting the list cleared up because a lot of the numbers that we call are no longer working, and a lot of the emails get bounced back to us. So if you know that you haven't gotten any emails from us, maybe contact us at outreach at OCA Astronomers to let us know which numbers are good or not. And if you're a new member and you want to give back to the community, reach out to us. We could add you to our list. Right now we have almost 50 volunteers on ground. So thank you all for your best effort to get science and star loving to the masses. And now a moment with Galileo.
Hello, my name is Galila, and today is gonna be the first quarter. Hopefully you guys see the beautiful moon and stars, and hopefully you guys have a good time.
Galileo. Thank you, Galileo. That was wonderfully done. Okay, so the Exoscope. Here is the agreement, and there's over 20 telescopes for you guys to, as a new member that you're here, you could totally do this program now. So we're looking forward to that. Here's the website. Researchers Telescope, and you can follow this here. The series Astronomer, guys. So we're always looking for wonderful content to make our community of OC astronomers richer and more connected. If you want to have an event that you've had or that you've want to share with the rest of us, please submit it to our editor for consideration to see if it clubs. We could put it in there. We would love to share all our stuff and all our achievements. So looking forward to seeing what you guys are doing out there during pandemic. Okay, so here we are. It's also electronic format. We're trying to get Saving Trees. So if you're willing to get it only online, here's how to register. Tell Charlie. And also the perk of that is that it'll be in color and you save a tree. So consider that. And again, we are discouraged from going, but if you do want to go, please know nobody that's cleaning after us. So make sure that you keep it clean. And of course, it's just be safe out there. Wonderful astronomers. And if you are there, or since you're there, might as well clear the weeds, right? Thank you for that. And just wherever you go, keep it better or just as you found it. The next meeting for us will be April 8th. So we'll see you next month. And now let's introduce to you our wonderful and fantastic John Garrett for our What's Up. Round of applause for John. Ooh. Thank you, guys.
Unmute.
Actually, he was a mailman, but he passed the civil service.
That's ridiculous.
Anyone else hear that?
Hi, John. Yeah, so you're on.
Okay. First of all, I want to thank the club because by having me do the What's Up, it inspired me to get out during some unpleasant weather to try to get images for tonight. And one of them that I caught is going to be, I think, the most unusual image I've ever photographed. I'm going to start by showing an image of a daytime effect that I photographed several years earlier. This is a circumzenithal arc, and it's formed by ice crystals refracting the sunlight. And this particular arc, when I saw it, I went out and got a photograph with my house there so I could use my house as a reference point to the zenith to illustrate how this effect occurs directly overhead. And that's why they call them the circumzenithal arc. And the sun in this particular photograph that you can't see is low to the horizon, but it's shining in the direction of the arrow, so it creates the arc that you see. Now, what I saw a couple nights ago is going to be something like this. I've taken my same setting with my house and I photographed Taurus, which is almost at the zenith this time of year. And so if you look right here, this is the shape of Taurus, the Hades cluster. And the particular night, a couple of weeks ago, there was a 5-day-old crescent moon. So it was low on the horizon. It was shining faintly from the direction that I've illustrated here. And I captured this image of Taurus. So what I was doing was at the early evening, I set up my camera with my 50mm lens, and I just pointed it at the Hades cluster of Taurus just to get things set up for the evening. I took a couple photographs, and then I went in and had dinner, and I was going to come back a couple hours later and get some photographs. But the next day when I'm examining my pictures, one of them had this very curious arc on it, which I enhanced a little bit by bringing up the contrast, and you can see that arc shape. And here I've positioned my Taurus picture approximately where you saw the circumzenithal arc in reference to my house, as my effort to convince you that I actually photographed a circumzenithal arc as opposed to other moon halo effects. And here's a full size view of that. So that was the most unusual thing I've ever caught. And the lesson is, if it looks like, a clear sky, there still may be a lot of ice crystals in the sky, even though it looks clear. And if there's a low hanging moon, why not point your wide field camera straight up at the zenith and maybe you'll catch something like this. I never thought it was possible that a faint crescent moon could cast this effect. So that was just kind of the big excitement, the big discovery of my life recently. Anyway, the moon, to which I am very grateful, eternally grateful. Here's the phases that it's going to be in this month. We have a full moon on the 16th. Which always puts a damper on stargazing because the moon's too bright to see much else. But by the 25th, it's going to be the third quarter moon, which means you'll have the early evening for good gazing. And then new moon on the 1st, which falls very close to a weekend. And then the first quarter will be the following 9th in April. And what that means for weekends, the weekend of 3/25, 25th of March would be a good one to get out and have good observing up until midnight. And again, the weekend of the 2nd of April would be a good one to plan to get to out to a dark site for an all night of observing. Here's a little view of what's been going on in the morning recently. And so this is a view of my neighbor's house. My neighbor's homes feature a lot in my photos. And the bright objects that you see here are the positions of Venus and Mars. And so you would see them about there if you went out tomorrow morning. And give you some context, here's the constellation Sagittarius, the big teapot shape, and the constellation Scorpius that you see, it's just its tail and stinger off on the far right. And supposedly Saturn is in here somewhere, perhaps somewhere behind these trees, but I couldn't find Saturn, but it's nearby. And anyway, the ecliptic is about here, and that's the approximate path that the sun takes through the sky. And so it's the approximate location of where we see planets. And what I want to call your attention to, this time of year in the morning, the ecliptic takes a very low angle from the horizon. So any planets you see in the morning at this time of year are going to be rather low to the horizon, and you're going to be looking through a lot of atmospheric interference as a result. Now, I just threw in this picture because whenever I can see Scorpius, I have to get a picture of it. So you can see Scorpius fitting in the right here, one of my favorite constellations. And this is a photo I took late in February to show some conjunctions that are going on. We had a nice conjunction of the moon and Venus toward the end of February, but we're also going to get a repeat performance of conjunctions with more planets at the end of this month. So starting the 27th and the 30th through the 30th, the moon is going to pass through next to a number of planets. And so I've kind of drawn the field of view. So we've got Capricornus off to the right in this picture, Aquarius in the middle, and I wasn't sure how Pisces fits in there, so I just drew Pisces off in the lower left as a big carp, Pisces the carp. And toward the end of the month, we're going to see Venus and Saturn and Mars all clustered in that area, and the moon is going to be passing among them. So toward the end of the month, it might be a good time to start getting up early and having a look at the morning sky. This is a view from earlier in the week of the moon, and I'm going to use it to illustrate how steep the ecliptic is in the evening this time of year. So this time of year in the morning, the ecliptic takes a very low angle, but the reverse is in the evening, it takes a very high angle. So if you look at the horns of the moon, the kind of the crescent shape, that approximately shows the ecliptic. The moon doesn't follow the ecliptic exactly, but it gives you an idea that the ecliptic is pointing up if you look at the horns of the moon. And now I've overexposed the same picture so you can see the context, see about where the horizon is here, and appreciate how high the ecliptic is. And the only planet that's in that area that makes it good for viewing is Uranus, is not too far from the ecliptic in this picture. And I didn't have time to figure out exactly where it is in this picture, but it is in the evening sky, still up pretty high for a good view. The rest of that night where I was photographing the sky, I was taking a 14mm lens, which isn't a very good lens that I have, and was photographing parts of the sky. And so here's Orion. And instead of using my recent photos, I'm going to draw on some earlier photos that I took at a darker night of Orion. of Canis Major and Taurus the Bull, and show you a few things that are still in the night sky if you look toward the south. And so here's the classic rendering of these constellations, Canis Major down low, Orion in the middle, and Taurus the Bull. And here is one of my favorites, Lepus the Hare. And it doesn't get a lot of attention, but if you look in that region, it actually looks like a rabbit. It's got the little face right here, its nose, it's got its ears, and it's even got a curved back and maybe a little fluffy tail. Of course, it helps if I add the ears and the body myself. It makes it look more like a rabbit, but I think it's a very plausible, very accurate constellation. But anyway, in this area are a lot of fine objects to look at if you haven't looked at them already. The Sword of Orion has the Orion Nebula. Everyone probably looks at that throughout the winter. There's other good ones for photography like the Rosette, and then great ones for binoculars like the Hades cluster up here. And M41 also is a great binocular and telescope object. But one of the ones that I really love this time of year, you can actually see it in this picture. If you look right here, you might see what looks like an orange or a red star. And that may look like a pixel error on my camera, but it actually is the carbon star R Leporis, which is a very beautiful star. And there's another carbon star in the view here, W Orionis. And over here in near Canis Major is a double star that rivals the optical double star called Albireo that we have in the summer sky. And so this one's often referred to as the winter Albireo. And if you haven't seen it this winter, you might want to hone in on that with a telescope. And so here's the bunch of objects in the sky to look for. And here is that that star I was just telling you about in Canis Major. And so it does look a bit like Albireo. It's got a nice contrast of blue and orange color. And here is, oh yeah, if we go back to the sky, I'm now taking my wide field camera and I'm pointing it up at the sky. And I think oh no, this isn't my wide field. This is Lepus the hare. So here's the snout, here's its eyes, and here's its ears. There, Lepus the hare. You can use Lepus the hare to find a few objects. You can use its little, these two stars to point approximately to the globular cluster M79, a good telescope object. Or you can use the ears, the rear ear, for example, to find this carbon star, R Leporis, right here. And so it's about the distance from here to there. Go a little farther and you may find that. And it's a beautiful star. Here it is in my small 3-inch refractor. And here it is with me deliberately unfocusing it to bring out the color so you can appreciate the color of this star. And now we go back to a wide field view directly overhead. We've got Orion here. We've got Taurus, the bull, and we've got the Pleiades. And this would be actually tilted a little bit if you were outside looking at it, but our screens are landscapes, so I have the whole thing tilted 90 degrees. But if you go this direction, you'll come to the constellation that I always mean to look up the pronunciation, Auriga or Auriga, the charioteer. And so I took a 50mm view of that, which will make it a little bit bigger. And so this I photographed for my backyard. And here you can see some of the open clusters that are directly overhead in Auriga, the charioteer. And these are great objects. You can see them in binoculars. You can find them in binoculars, and you can see them very nicely in a telescope. And if we go back to Auriga, the charioteer, and then go this direction, we come to the constellation Gemini, the twins. And so here's Castor and Pollux, the twin stars, and the Gemini twins bodies go out this way. And even in this picture, you can actually see M35, a very popular open cluster to look at in Gemini, but there are a lot of other treats to look at in Gemini, and Gemini is directly overhead right now. So it's a good constellation to spend some time with in the early evening. Here's a photo I took of Gemini many years earlier at a very dark site where I let the camera soak for about 3 to 5 minutes. And you can see that you've got a lot of dark nebula and red nebula in the field of view. And here is the classic constellation and the star names and how it's traced out. And it's not too far from the constellation Canis Minor, the little dog. But some of these objects over here, you've got the Rosette Nebula, you've got the Cone Nebula. These look like a nebula, but all of these are good targets for telescopes or long-term exposure. And then down here is a couple objects that were new to me this year. And so there's NGC 2371/72 and NGC 2392. These are planetary nebula that are directly overhead in the early evening, and I urge you to take your telescope and see if you can see them or at least photograph them. The wonderful thing about planetary nebula is that even a small telescope, if you get a minute on that area, these things will pop out for their green color. And so here is that planetary nebula 2371, 2372 that was named two separate NGC catalog numbers, but later was discovered that they're actually the same object, the same planetary nebula, which is essentially a dying star that's blown out its outer layers. Now, the same object in a larger telescope, you may be able to see the double lobes. And so I wasn't able to see this from the city, but I'm eager to find out if you can see it from a dark location, but it's fairly easy to photograph from the city. And so here it is photographed with my 8-inch Schmidt-Cassegrain telescope at a prime focus, but with a focal reducer image that brings it down to a focal length of 6.3. And then here's another one that's just a real gem. The other planetary nebula in that area. This one I could see in an 8-inch Schmidt-Cassegrain telescope. And it's really nice because the planetary nebula is right next to a star. So you get a very good contrast between the star and the nebula so that you really know that you've seen the nebula, because you'll see a star as a point of light. The nebula will be slightly fuzzy. And here it is zoomed in with my 8-inch telescope. And you can see the planetary nebula, essentially a dying star that's blown out its outer layers, and those outer layers are being illuminated by the core of that star. And beautiful thing to look at. This shows up, at least I saw it well, in an 8-inch telescope from my city, which is fairly light polluted nowadays, like isn't everywhere. Anyway, so these are some things to see in the sky. You get the tail end of the winter constellations. The spring constellations are rising in the east, and those will be, for another What's Up. But thank you for your time.
Thank you, John, for yet another great presentation. Hi, my name is Reza, and I'm the Vice President of the club. I, too, would like to welcome you to the March 11th, 2022 General Meeting of the Orange County Astronomers. Our speaker at this meeting joined the physics faculty at John Abbott College in 2006 with active projects in STEM education and pedagogical development. He is also the public events coordinator for the RASC Montreal Center since 2016, helping reestablish the I.K. Williamson Astronomy Library. He is the 2021 recipient of the Charles M. Good Award. He is currently working on a project to create student activities using satellite data in the classroom. Please join me in welcoming Professor Karim Jafar. Karim.
Thank you very much, Reza. It's a pleasure to be here. I wish I could be there in person. Here it's -4. It's snowing outside. It's Montreal weather. Always gray, always cold in the wintertime. I would much rather be out in Orange County. And it's been great being a part of this meeting. One of the things that I'm loving these days with Zoom is that you get to see how other centers and other clubs run their meetings, how they run their societies. Just the sheer size of your society, I'm in awe. It's fantastic. So I'm looking forward to sharing with you a little bit about what we've been doing here in the Montreal area, and specifically what I've been doing at John Abbott College. So let me just share my screen, and you can start to see a few of my students and a little bit of what we've been doing. And bringing astronomy alive is really the way I approach astronomy teaching. And it's the way I approach science teaching overall. But when I got a chance to teach the astronomy course, One of the big things that I wanted to do is I wanted to reach the students no matter what background they came from and no matter what career path they may be going to. Here you see a group of students, of which actually 4 of these students have continued on in astronomy, astrophysics, geosciences, and planetary sciences. One started in that area, but has gone into social science. And one of them is currently in geology, but looking more towards mineralogy here on Earth for environmental sustainability. So the students that come into my class are science students, but they're not necessarily science students who have a plan to pursue space sciences. One big example that I have that I wanted to share with you was one of our students who's, sorry, I'm just trying to get this to click. There we go. Catherine Dulong, who became our RASC Center president here in Montreal for a year during COVID times. And Catherine, when she was a part of our outreach group, she would talk about just the way in which astronomy makes her feel. I love the way my heartbeat slows and my pupils expand as I stare up at the night sky. The night sky makes me feel alive. It makes me feel human. It makes me feel real. But no matter how much I love astronomy, I will never formally study physics. And this is kind of the underlying difference for me in terms of the way in which I teach astronomy versus the way in which I approach astrophysics. And both of those are science option courses offered at the college, but I ended up taking on astronomy as my challenge. And so what I want to talk to you about today is a few things. I'm going to talk to you a little bit about the way in which I approach astronomy, the way in which I get the students to look up, but also the way in which the students contribute back to our Montreal Center of the Royal Astronomical Society of Canada. Now, the Royal Astronomical Society of Canada is 150 plus years old, and our Montreal Center celebrated its centennial when this picture was taken. We had a fantastic event. The students made infographics of absolutely everything to do with space, and we posted them all over. We had the Canadian Space Agency come to give a talk. We had a reception banquet. We had a cake made by one of the students who's also a baker. And it was just a fantastic celebration of all things RASC Montreal Center. Now, since COVID started, I've become active in other areas, especially in outreach. So I just want to mention a few things to your audience that they may be interested in. First off, with Explore Alliance, I am an ambassador with explorescientific.com/live. We run global star parties every Tuesday night for everyone. And it's speakers, we start off with David Levy, the famous comet hunter, David, who's based now out of Arizona, but is originally from Montreal. David Eicher, the editor of Astronomy Magazine, is one of the presenters every year or every Tuesday. And the Astronomical League is one of our co-sponsors along with Explore Scientific. So our host is Scott Roberts. It's a fantastic environment. It's a lot of fun to be part of that outreach every single week, and it kind of keeps me going. And through that, I've become involved in the Astronomical League. I've become a member of the University Lowbrows in Michigan. And I also, at the same time, reached out to people across the sea, across the pond. And I'm now a panelist in the Reach Out and Touch Space radio show on Astro Radio, which is a volunteer radio station, 24/7 astronomy and music. And the panel show is on Mondays at 8 to 10 British time, which for me is, smack in the middle of the afternoon, 3 to 5. And for you would be, your lunch hour from 12 to 2. And so it's a fantastic show, but it also replays throughout the week. And we get to talk about all things astronomy, bring in guests, talk to them about what made them first feel alive under the night sky. Now, with all of these different outreach activities, one of the things that we've realized is that there's a need to really motivate the youth to embrace astronomy in a way that they feel comfortable with. I'm going to talk to you about how I do it at John Abbott College, but I'm also now part of a mentoring group for the Cosmic Generation, which is the first international committee for youth by youth. They run workshops monthly, and the next workshop is this Sunday. It's at 3 p.m. Mountain Daylight Time. It's on size and scale, and it's being presented by 2 of the youth, one from Denver and one from Victoria, BC, right north from you in British Columbia. And they're going to be talking about the size and scale of the universe, but in a way that hopefully makes it a little bit more accessible to youth. So any youth under the age of 18 are invited to sign up to attend the workshop. And if they're interested, they can even become an active part of the Cosmic Generation. And this is a group that we are co-sponsoring between the RASC, the Explore Alliance, and the Astronomical League. And we're trying to provide them with as much support as possible, because really what I heard when Galileo talked to us about the moon, that just pulled at my heartstrings. I love that. I love seeing the youth involved. And that's really the reason why I do what I do. Before we get into any of that, I always try to start off our RASC Montreal Center events, as well as all of my outreach, with a land and sky acknowledgement. The land acknowledgements is something that's become a little bit more traditional. A lot of people do that to recognize the fact that we are typically on unceded lands, but we also have to recognize that the stories of the sky and the observations of the sky are not just ours. They've been there through the dawn of time. And so lately I've gone around giving, actually across the globe, through Zoom and through Teams and Google Meets, giving talks about what's called two-eyed seeing, which is the ability to try to connect Western science along with ancient and indigenous knowledge. And so, for example, we have the worm moon, which is coming up in about a week. We're right now at the waxing gibbous, but the worm moon is the way in which most of the settlers called it when they came to North America. However, the Micmac Indians here in the east part of Canada, they call it the maple sugar moon, as do many of the other Indian tribes or First Nations tribes here in Canada, because the maple sugar is right now the most precious commodity coming out of the trees. And there's a fear, if you don't tap the trees themselves will snap through the thaw and through the freezing and unfreezing, freezing and unfreezing. And so we recognize that they see something within nature. Now, realistically, right now, we're not at the full moon yet. This is a picture taken just earlier today by one of my friends in England, Roger Hyman. And so we are at this beautiful waxing gibbous moon. And so I know my students are trying to look up through those clouds and through the snow. And tomorrow night, hopefully, we'll have a little bit of clearing and they'll start taking some snapshots of the moon. So for those of you who don't know where I'm calling in from, I'm in Montreal, Canada. And so I figured the best way to do it was to give you a map of North America and show you where Montreal is. And for astronomers, what better map than a light pollution map? So there's Montreal. It's that huge light sink right up there by the St. Lawrence River, right at the eastern edge after you pass the Great Lakes. We are the third worst light polluted city in terms of per capita per year in the entire world. Now, it doesn't seem like it when you look at that picture, but what you have to remember is we are surrounded by snow and ice for a large part of the year. And a lot of our lighting ends up reflecting off of that, creating a total amount of ambient light that's above just the artificial light that's being created. So Montreal is a real light sink. And if we zoom in with a picture taken by David Saint-Jacques from the ISS, we can see that the city, which is surrounded on all parts by water, it really is an island, is entirely lit up. There is no real clear area where there's dark anywhere in the urban center of Montreal. However, if you look over there on the western edge, there's a tiny area of darkness, and that's where our observatory is for the RASC Montreal Center. We have a 14-inch telescope in an observatory. The observatory is run by one of our neighboring universities, McGill University. And this is their plot of land where they do a lot of their environmental and biological research on plants and on animal life as well. But it's a protected area. And so during COVID, we've had no access to that. Now, I'm very lucky. My campus is right near there. It's actually just on the southern tip of that same area of the island. And John Abbott campus is where we tend to host a lot of our public events when we have a larger public or when it's a daytime event, because it's just a little bit easier to get to by public transportation as well. Now, when I came into teaching astronomy, one of the things I had to be aware of was the fact that there was this variousness to the background of these students coming in. They had very limited curricular exposure to astronomy here in Canada. I know in the States with the NSTA standards, you have a fair amount of space sciences covered in elementary and high school, but a lot of it depends on the background of the teacher in terms of how deep they go or how comfortable they are with that. And so what I find is that most students, when they come out, they have some knowledge of some of the objects in the solar system, some of the objects in space they may have heard of. They know a little bit about gravity and the way in which gravity works, but that's about the limit to which their knowledge goes. So that's the starting point for when I get them. Then I start asking them what they know and what they do. And it turns out that a lot of them do love to read about or look at the night sky. They watch TED Talks. They watch these occasional videos on space.com. Only 10%, actually less than that most terms, are people who would consider themselves to be backyard astronomers, and very few of them have prior exposure to amateur astronomical clubs. But the way I treat this is a way that seems to separate me from some of the other college teachers I've spoken with, where they see that as a frustration. I see this as a benefit. Just like when we look at the sun with different wavelengths of light, we see different features and we see different chemical reactions, different levels of energy, where we can learn about the processes and delve into the depths of the sun. I find when we have discussions about topics, the students coming from different backgrounds, having been exposed to different materials, different teachers, some coming from an English system and some coming from a French system, and even some coming from outside of our province here within Quebec, there's a lot of variety and perspective and in depth. And so our group discussions can become incredibly complex, but also incredibly fruitful, because you start to really delve into all the different areas of space exploration, of the way in which astronomy works, of whether or not we should have Starlink going up and how good it is versus how bad it is, whether or not our spending money on space exploration or on exoplanet research is as worthwhile as spending money on remote sensing from Earth observation satellites that can give us more information we can use to solve our problems directly here on Earth. It's incredible to see the way these students start to dive into some of these discussions. Now, the level at which I teach is not high school and it's not university. It's closer to something that you might refer to as a junior college. But what we do here within my province of Quebec, within Canada, is unique even within Canada. No other province has this. The very last year of high school, what would typically be grade 12, and the very first year of post-secondary studies are put together into this separate institution called a cégep, or a college, which is where I teach. So we get the students at the point where they're ready for not just the focus of the introductory level that they need for their career path, but also to be exposed to just a little bit of that expert level, just a little bit of depth. And if you can spark an interest, if you can show them something that really ignites their passion in science, they can take off from there if they want to. And so what we tend to find in the way I would teach my course is by the time the course is done, between a quarter to 40% of the students are trying to find out if their career path has an overlap in astronomy, in astrophysics, or in space sciences. And most of the rest are at least aware that even if it's just a hobby and an interest, there's an area where they would be welcome for that passion, which is the amateur astronomy groups like the RASC Montreal Center or like the Orange County Astronomers. The way I do this is what's really unique. And I don't want to spend too much time talking about it because I don't want this to be a pedagogical talk, but I let my students direct the course. I give them a survey of topics, and from that survey of topics, they choose where we spend the most time. And then for every single week, the pre-class readings are not out of a textbook. They're out of resources chosen by other students. And then their projects that they go into, they have a wide range of choices on projects, and they go as deep or as far as their group decides to go. And most of the time, they're reporting back to me, there's a certain amount of prescriptive work and then a certain amount of open-ended work. And then I show them as many opportunities as possible for experiential learning if they're interested, but that has no marks associated with it. So really not just the course breadth, but also the depth and the direction of the course, and even some of the classes, goes into the hands of the students, even though they don't have a background in this, because they read ahead and then they choose how deep and how far we're going to go on those different topics. And later on in the Q&A, if you want to know more about how I do that, I'm happy to spend some time delving into it. But what I want to talk to you about is the way in which I made this for everyone, but also the way in which we were able to mirror my approach with students to our approach in outreach to the general public. When I started, I had no background in observational astronomy. I knew a lot of the physics. I knew a bit of astrophysics, especially at a higher level in gravitational wave theory. And I approached physics as problem solving. So I wasn't scared to learn material I didn't know. But I'm a theoretician by heart from when I was in school. And so the idea of becoming an observationalist, I was a little bit scared. And it was not a course that I originally thought that I would ever teach. I thought I would teach astrophysics. So when I had the opportunity to teach astronomy, I spoke with my family and I said, you know, we're all interested in space. Do we want to do this together? Do we want to join a club and do we want to learn astronomy together? And they were like, what are you waiting for? Grab the keys. We're getting in the car. Let's go. And so we went to our very first RASC Center outing, and I was amazed with the reception, the openness. There's these two kids who don't know anything really about observational astronomy, and they're taking them from telescope to telescope, telling them what they see, sharing the view at the eyepiece, watching and showing them how to turn telescopes, how to move them, what it is that they're doing, why they make a choice of this eyepiece versus that eyepiece. And that's what I thought students need to see. So I approached the club and I said, you know, is there a way we can make a partnership between my college students and your club? And they're like, well, we actually have a partnership, but nobody talks to us there. We just have a little basement room where we have some library books and we get together there once every month. There's about 4 of us who show up and we look through some books, and occasionally somebody asks to borrow a book. And that's our partnership with the John Abbott College. And I said, okay, that's no good. We need to do more. So we found a new library center location that's much bigger, that allows us to do a lot more. And then we started collaborating on public talks, on member workshops, and I took over the public outreach and the public events coordination. When I did that, I connected it directly to the Student Astronomy Club, and I invited them to tell us what topics they wanted to listen to, what types of speakers they wanted us to get. And naturally, they started volunteering to give talks and also helping to organize the logistics of some of the outreach and some of the events that we do, which enabled us over time to really broaden and deepen our outreach offerings. And I'm going to show you snippets of that over the next half hour, 40 minutes. One of the big things that we did is we ensured that any of this part was optional. There was no marks associated with any of this before COVID. Once COVID started and we started recording our public events, I started being able to offer the public events instead of NASA videos, or instead of, you know, a video from 5 years ago in one of the Cosmos episodes or from one of the Discovery Channel programs. I could offer them to watch a video of a speaker chosen by students and moderated with a Q&A moderated by one of their classmates. And that became a much richer part of the course. So if they attended live, they could skip that class. And if they didn't attend live, there was a dedicated class period to watching and then a discussion afterwards with them. I also started linking up some of their project offerings with some of the RASC astronomers who showed an interest in not just citizen science, but also in mentoring youth astronomers. That even came to the point where we had a member who, unfortunately, he passed away at the start of COVID, but he was a member of the Canadian Press. And so he mentored one of our students who was one of the writers for the student newspaper Bandersnatch. And she now runs a new magazine at the university that she goes to, and ended up running as a chairperson for a national committee in the RASC. This is them interviewing Steve Iris, who was the mission commander for the RadarSat constellation, which is 3 satellites that go through in a wonderful polar orbit to do Earth observation analysis. And the previous generation of it is currently now privately owned data by MDA. And then we have our students exposed to outreach and exposed to these moments where a kid or their parents or a whole family just starts to, the passion, the moment just seizes them. You know, that moment where you've shown somebody the rings of Saturn for the first time, or the craters on the moon for the first time, or they see those dots beside Jupiter and they realize that those are moons around another planet. Those moments that we cherish in outreach and that we cherish as amateur astronomers going out on our own under the night sky are moments that stick with these students, because they realize that they've opened the eyes now of somebody else to something that they themselves find fascinating. And so they start volunteering as early as week 2. So we give them access to as much as we can, whether it's the observing telescope where they can go in and talk to the telescope operator and learn how the dome works, whether it's pulling out our own Dobsonians or, you know, a nice computerized Nexstar out on the field and training the students so that when it comes time to observing the 2017 partial solar eclipse, it was a student running the telescope the whole time. Or whether it's celebrating with these older astronomers the first light for a brand new 16-inch telescope from Explore Scientific that we have at our dark sky site that's a little bit off island. As the partnership evolved, we started having more and more events where all of the students and all of the members together got to be a part of sharing astronomy and sharing knowledge and meeting people and experiencing moments under the night sky. And all of that kind of centered around this partnership, which is based out of this little library room that we have, where not only do we have a library collection and a old references collection, we host poster nights, we host speakers, we have our board meeting discussions, and we even have this wonderful little shelf dedicated to David Levy, and he donated to us this beautiful little refractor telescope that he'd gotten from St. Mary's University in Eastern Canada from a estate of a professor who had passed away. And it's just a beautiful, beautiful little memento. And when he came to designate it, he mentioned how great it was that it's not going to be just hidden in the bowels of a basement somewhere, but it's going to be appreciated, not just by the astronomers who know where this comes from, but also by younger astronomers who will ask questions about it. So our outgoing president at the time, Maury Portnoff, gave this quote, and he gave a presentation with me at a big space symposium talking about this partnership. And what he said is that the John Abbott College students have become an integral part of the Montreal Center by not only attending observing sessions, but organizing events, giving presentations, and even becoming paid members once graduate. Now, this is important to recognize. When they're students of mine, or when they're members of the space club at my college, we don't charge them any membership fees. They are partners, and we made sure that our insurance was written in a way where those students as attendees could also volunteer as helpers and help do logistics and things like that. And so when we do events, they help run things, they help set up, they come and provide the knowledge that they gain from the class. The very same night, sometimes they're sharing some of that knowledge in an outreach event. And it's wonderful to see them blossom. And so in the middle here, we have Julian De Silva and Sabrina. Julian was a young student who volunteered to give a presentation on his research project with the course. And he ended up traveling with me to Toronto. He stayed in Toronto for a conference. Toronto is about 6 hours away from Montreal. It's 600 kilometers away. And he gave a presentation about the benefits of learning about spectroscopy from an outreach perspective. And his goal was to get people to realize that when you show people in outreach the night sky, you don't have to stick to very faint nebulae and galaxies that you have to wait to stack. You don't have to just show them the moon and a couple of planets or maybe one cluster. You can teach them science. And his point was that if you take a specific star or a planet and you break up its spectra, or you take a double star like Albireo, which we were mentioning earlier, which is two different temperatures, and you break up the spectra and you can see that those two rainbows have different colors, you're teaching them science at the same time. And he was so impassioned, he got a standing ovation at the end of his talk. I was so proud of him. These projects that the students get to do sometimes will stay with them for a very, very long time. One of the big things that I found when I started teaching was that we didn't have enough access to equipment for students. The previous teacher would typically have one observing night during the entire year where he would pull a telescope out into the oval to show the moon, and maybe if there's a couple of planets up at the same time, and it was at around 6 o'clock in the evening, and then at 7 o'clock, everybody would be gone home. And that was the extent of it. When I started doing this with the RASC Montreal Center, we had weekly observing nights possible if it wasn't cloudy, and at least a couple of students would come out a few times a month to different events, and it was amazing. But there were a lot of students who couldn't come out to these organized events, and so I wanted to give them something that they could take home with them. So the first thing we did is we dug through all of the storage, and we found these 5 awesome Dobbs that are just insanely heavy and so hard to move around, but we built them all up and we tried to get them out, and the students had no way to carry these things home. They had no way to take them home, to take them out, to set them up, and to be able to use them easily. They're just too unwieldy. So I invested in a series of binoculars, and here I really lucked out because I bought a couple of binoculars used, I bought a couple of binoculars new, And then I went to Stellafane in 2018. And when I went to Stellafane in 2018, there was a young gentleman there who had decided to take as a project, picking up old optical pieces and refurbishing a bunch of binoculars. And when he found out that I was looking for them to donate to students to borrow, he gave them to me at cost, which was basically around $7 US per set of binoculars. And so I still have a bunch of these binoculars, even though I've managed to now get some money to invest in some new ones, and then to also invest in some better portable telescopes. So at the moment, we have a couple of Heritage 130s. We have one small Meade 80 millimeter, and we are currently working with our local library at the college to try to mimic the library telescope program in the US especially, but now there's a few in Canada that also are doing the library telescope. And we're trying to get the Orion Star Blasters to have available for students to borrow from media services. So I no longer have to do all of the borrowing, signing, cleaning, and everything myself, which is what I've been doing. The one thing we've been able to do is incorporate in DSLR photography into what we expose the students to, and smartphone photography, so that they do still have a way to look at the night sky and capture a little bit of the movement and the beauty of the night sky, and start to understand a little bit of what they can do themselves, even if they don't choose this as a career. If they do choose this as a career, they start to realize the different tools that are available to amateurs so that they can start doing some of this themselves, even while they're still in undergrad and they don't get access to the larger research telescopes. So what you end up having is you have a whole range of students with different interests, all getting a little bit of exposure to equipment and how they can use that equipment. So with all of this, once they've gotten a bit of time to get used to the approach to the course and to the types of equipment that they can use and meet a few of the RASC members, we would set up their major project. And pre-COVID, I would let them run wild. Whatever they wanted to do, if I could find a way to help them do it, we would do it. Whether we built a radio telescope on the football field at one point, we made optical telescopes in the workshops late at night on campus. We would get security swearing at us because we were there at 10:30 at night and they wanted to close up and the janitors wanted to come through. We had individual who was really, really interested in water resource management who wanted to do tidal forces. So he did tidal forces for his project and learn more about the way in which tidal forces differ between the moon and Earth versus Jupiter and Io, for example, or the sun and Mercury. We had individuals doing programming of orbital mechanics, everything from video games all the way through to programming their own code. And then we had some that were really interested in historical topics or in the space race. And they approached it much more from an anthropological perspective or from a historical study perspective. And one even went through and tried to build in the old ancient 3D model of what the Chanquillo Solar Observatory would have looked like. When COVID hit, I realized that I couldn't really run this gambit of all these different projects, but I still wanted the students to do some real astronomy. That was the key for me, is I wanted them to learn how to do real astronomy, but with simpler tools that we would have access to. And I also wanted them to recognize that there's this entire area of citizen science where they can become active participants in research, even if they're not directly doing graduate studies in that field at that moment in time. This also led to sharing these exact same initiatives with the entire club, the RASC Montreal Center, and also presenting it to other clubs across the country. So the first project that we really dove into, we started before COVID, but then it became one of the standard projects for my course every term, which is Exoplanet Transit Observation. And I'm going to share with you a bit about that in a few moments. I also found a lot of students loved astrophotography. So I built a couple of labs about astrophotography, which I'll show you as snippets of in a few moments, but they had a choice to really dive into astrophotography within their project and learn how to even stack, thousands of images, if not tens of images, if not simply comparing narrowband versus RGB for the same target. Spectra of stars still remains a popular choice. And we use the RSpec software and the Spectral Analyzer 100 grading. And Tom Fields is just an incredible mentor to these students. He still communicates with a couple of the students who finished the project years ago and still chats with them sometimes on social media. I just love it. I also teach them how to access solar system probe data so that some of them choose to do analysis of that. And then I was very fortunate to attend SEEK virtually last year. SEEK is the space education conference. And we learned a little bit about Orion's Quest, which does analysis of biological research aboard the ISS. And so I've managed to become one of the only Canadians who has students who do that analysis in real time. We also offer students the ability to choose a topic if they don't want to do real research, but they want to still do something in terms of a project that dives a bit deeper into an area of interest for them. And so I let them work on communicating astronomy, creating some small video segments on either different topics within astronomy or on tools that they've learned how to use in the course to provide step-by-step guides to the rest of the college community that doesn't get to take the course, because only 35 to 40 students get to take this course every term. And it used to be only offered in the fall, but now it's offered both terms because of the demand for it. I also, as Reza was mentioning, I this term developed a project that a couple of, well, two groups are actually piloting because there were a lot of students interested in it this term, which is accessing Earth observation satellite data and learning how to model different climate emergencies or climate change features and show them from real data and walk through how to do that either as a research paper or as a lab that they would build. And all of these projects, the final product, the only thing that's actually graded is a poster of a research style poster. So they get a little bit of exposure to what it's like to do real scientific research and try to communicate it to an audience of other scientists. And then this term, because I always let students tell me if there's a different project they want to do, there was a group of 3 students interested in music, of which one has been accepted into sound engineering and one has been doing some sound wave transformations since early high school. And they asked if there was something they could do to combine their love of music with astronomy. And so I've introduced them to sonification, and they're currently working on what their project plan is going to be, whether they're going to look at radio waves from Jupiter and the sun, or whether they're going to look at trying to take photometry of digitizing images and turning that into music, or looking at different variable stars or exoplanet periods and trying to make that into music. I'm giving them full berth in how they want to do this, and then I'll support whatever direction they decide to go. Now, with the RSpec spectrum, one of the wonderful things that comes out from this is it connects what they're seeing in astronomy directly to what they've seen in chemistry courses and what they see in our optics and modern physics course. So they learn more about the way in which not just stars work, but also the way in which this light works to get to us from those stars. And the groups that decide to delve into different temperatures of stars see the different features of the depth of the Balmer lines. The groups that try to compare stars that are regular main sequence stars to a star that's like a Wolf-Rayet star where you have emission lines as well, they see the complete difference in the type of curve when you have emission and continuous spectrum versus absorption and continuous spectrum. So the science within this is fantastic, but as I mentioned, it's approachable even for outreach. And so the spectral analyzer, when we use it, we have just this little grating that we tie into the eyepiece and we stick it into the telescope. And so if you're looking at Vega, you get this beautiful spectrum of Vega, like I showed on that earlier slide. People just come up with their cell phones and just take a quick snapshot at the eyepiece, and they have the spectra of one of the brightest stars in the night sky. It's amazing to see how wonderfully that's received by a general public that doesn't necessarily have a science background. The idea that our sun isn't the only star that gives us rainbows, and that those rainbows are different from star to star, it sticks with them. And it's a little bit of science that you've given them on a night where they came out just to be under the stars. And that's one of those things that the students really love to see, that sort of an impact. Now, a lot of what we do in our projects is used by using robotic telescopes. Now, I know you know about LCO, and I'm lucky enough to be part of the Fox telescope project in Europe. And so I get access to a lot of those Cumbros telescopes. I also get access to the school's telescopes over there. And so for the astrophotography, we have choices of targets from the northern and southern hemisphere. But for the exoplanet transit observations, we use the robotic telescope that the RASC runs in the Sierra Telescope Complex in California. And the whole goal here is simply to first observe a transit. And to observe a transit, you have to see the starlight dimming in a perceptible fashion. So students learn how to choose a transit to look at of a known exoplanet. And the very first group to do it, and I was hoping to show you the video tonight, but we were having some difficulty with the video earlier, but it was a group that chose HAT P16b. And it was the first time we'd done the project. So we just chose to do one set of transits. They got about 400 images. They took the 400 images, and halfway through, there was a meridian flip of the telescope. So they had to find where that happened, take the last batch of images, flip them around, and then stabilize the whole set of images, not to stack them, but so that when you choose a point to track the photometry for that point, it's actually tracking the same star from grid to grid to grid to grid, from image to image to image to image. And so then you do that for your chosen star and for a few reference stars. And what's wonderful about this is in order to do that, they have to learn to see a sky map with 190 stars on it and figure out which one is the one that they were choosing. And that whole process of figuring out what star they're looking at based on an RANDEC signature is one that's incredibly difficult for these students. So we give them an annotated sky map for them to start from, but when they see these plain images, they have to take that annotated sky map and they have to connect them. And that's a wonderful process, and it gives them a real indication of how research is done in these photographs that are taken. You know, Gaia satellite takes 1.8 billion stars and churns out all of them in December 2020, and we have all this data. How do we know which star we're looking at, which star is which when we go from one frame to another? This is the type of research they're being exposed to. It would be fantastic if we had precision to actually pull out some atmospheric features from the ingress and the egress of the transit, the start and the end of the transit. If we could pull out a little bit of atmospheric absorption lines, that would be incredible. But you can see with the scatter of the data, we don't have that level of precision. James Webb will. And the James Webb data, one of the local students, Olivia Lim, she took for the exoplanet system TRAPPIST-7. She is going to be working on a project with the James Webb Space Telescope to take the atmospheric measurements at the ingress and egress for the TRAPPIST system. And she's going to be giving a talk for us next month in April about this project. And their hope is from the very start to make that data available for citizen scientists. So the students who've done this exoplanet transit project with the RASC, they will have the skills necessary to pick out and then learn how to analyze for the atmospheric signatures that she's hoping to get for her research. This term, we decided to add something new. And this is kind of cool, is we took known exoplanet transits, and the students still have to characterize a known exoplanet transit. And you know, most of the time it's nice and smooth like it was with HAT P16b, but this past fall with HAT P32b, we had clouds come in, and then we had a humidity spike, and you can see that humidity spike at about the Julian date 1.019, and all of a sudden you had a brightening of all of the stars because of the humidity spike, and then the roof had to close early. So we didn't actually get the full transit, but we could see enough of a dip to say that HAT P32b there in blue had a dip, there was a perceptible transit. Now the students that term decided to pilot a project to look at test objects of interest. These are unconfirmed exoplanets. And so those unconfirmed exoplanet transits, you still have to treat them the same way, but if you see a perceptible dip that's beyond the scatter of the data, and these guys were close, but unfortunately when you do the statistical analysis, it's just not clear enough. But if you can get a clear enough dip, you can submit it so you can be part of the confirmation process for a test object of interest. And that's one of the new things that we've added in. And this current research is going to be published in the next edition of Sky News. And that's one of the neat things that's come out of this is the students get a chance to use the robotic telescopes to do all of these real research projects, and then they can get published for it. A college student who's not started their university program yet is published in a periodical for amateur astronomers. And if they're article is done well enough, we're hoping that we can get them published in our literary research journal, the RASC Journal. Unfortunately, up to this point, we have yet to have one that was full enough for us to submit into that, but we're hoping soon. The other thing we get to do for these different image processing labs is we get to teach students what calibration is. And this is important because when they do the Exoplanet data lab, one of the first things they have to do is figure out where the meridian flip happens, stabilize it, but then they also have to apply the darks, the flats, and the biases. So in lab, before they do these projects, I teach them about that. I take a single image of Andromeda and I show them how to take that tiny little speck that you see and pull out this image right here. And they go, oh, wow, this is fantastic. And I say, yes, now let's just take 4 images like that and stack them. And all of a sudden they can see the increase in detail and how much more prominent the detail is from the noise. And then I teach them to apply the calibration frames. And now they get something a little bit closer to the type of picture of Andromeda that they're used to seeing in textbooks and magazines, etc. And so I teach them a little bit about the way in which calibration works, the reason why you would do stacking, so that if they choose to go this direction in their project, they've already had an introductory level, just an activity, but it's one that the whole class participated in. So they don't have to teach that on their poster. They can dive right into the area that they find most interesting. The other thing that I try to do is I try to show them the difference between full luminance and broadband, as well as narrowband. And so in order to do this, we use the RASC robotic telescope and we take a simple little target like M42, the Messier Nebula, or sorry, the Orion Nebula. Those are the types of pictures that we normally get from our smartphone at the telescope, right? That's fantastic picture. Look at how little noise there is because we did this one with a nice long exposure, but that's the picture that we normally see. And I give them an RGB version of this and I show them using GIMP how to draw out the detail so that they can get something much, much more vibrant. And then I let them really jump to it and they all submit different types of pictures. Some of them try to get as much of the dust of the nebula as they can, as excited as they can, show off colors as much as they can, even to the point of false coloring it, but that's okay. I don't judge them on the subjective. I ask them what they're trying to show. And this particular group was trying to show the dust boundaries outside of the core. And I thought they did a pretty good job of that. Another group that tried to show the core a little bit better subdued those dust boundaries, and now you can actually see the trapezium through the core. And those types of processes, giving them a little bit of exposure to that, I find incredibly beneficial because they start to see that those pictures are actually attainable from relatively straightforward equipment, because the telescope that we have in California is not a telescope you can't have here. And a lot of the astronomers that we work with have better telescopes than that. But it's in a darker sky and it's stabilized so that we can use it when we need to for these types of projects. The other thing that we try to do with these students is we try to expose them to where to access citizen science, not just in astronomy, but in all areas. So we talk to them about Zooniverse. We show them the very first citizen science type project Zooniverse started with, which was Galaxy Zoo. They do an entire lab on that, and then they investigate the other areas of citizen science within Zooniverse. And this is one of the sets of articles that was published in Sky News, where one student loved the idea of gravitational waves. So he just jumped into that project. And another one thought that Radio Galaxy Zoo was even more impressive than Galaxy Zoo. So she wanted to talk about the double lobe sources and what they mean and how to find them. And again, these students may continue on in astronomy and astrophysics or physics and math. They may not. But this idea to them that they can be a part of real research on their spare time, it's incredible what this brings them to afterwards. Now, that's all well and good. And those are the incredible projects that we can do if we have a long period of time with the same dedicated group. But what can you do with a group of students you only have for a couple of hours, or you only have during one particular outing? And one of the first things that I do with my students at the very start of the term is I try to get them to look up. And what I try to get them to do is to sketch the moon. Some of them take out their cameras, they take pictures first, and then from that picture, they try to sketch what they see. But I ask them to look at the sky, look at the moon, draw what you see. There's no marks associated with the quality of the sketch, but you have to sketch. And once you sketch, I need you to identify 2 of the features, and I give them a moon gazer's guide. And I say, tell me the mares you see. Tell me one of the craters you see. I want to see what you can identify. I take binoculars and I offer them to take binoculars home with them. I bring out telescopes if it's possible, if we're allowed to be in person, but I just need them to look up. And this is the quote from one of the students. This activity made me observe the sky more than ever. Although only 2 observations were required, I went out many times to simply gaze at the moon. I would first look for Tycho and then use it as a reference to compare my observation with the RASC guide. That's what I do when I go out. I look at the moon, I spot a couple of features, and then I orient myself. And then I pull up the binoculars and I spend some time on the Terminator, and I look at the Alpine Valley. I look for Copernicus if it's, waxing gibbous or full moon. And I spend some time on the areas that I enjoy seeing. But I start by just looking up. But when you're looking up, it doesn't have to be at night. It can be during the day too. So I teach them how much information we can get out of simple observations of the sun. And this is something that I even do in short outreach workshops, because what you can do is you can access something as simple as star trails and figure out the sidereal day by knowing that the star trail was taken for 2 hours, figure out the size of the arc, which would be about 30 degrees. So for 360 degrees, it'll be a 24-hour day. And then you ask them how you figure out the solar day. And you can go to and access something like timeanddate.com for every single spot on the entire globe. And for that spot, you can figure out sunrise, you can figure out sunset, and you can look up the altitude in degrees at local noon. One of the first things I teach the students to do is to go out and measure the height above the horizon of the North Star. And if they can find the North Star and they can find the height, they have their latitude in the Northern Hemisphere. So they know what altitude means, and this is now going to be the altitude to the south or to the southwest or to the southeast. And I want them to see and to take measures of something tangible, so I don't have them measure the sun because that would burn out their eyes. So for the sun, we look it up on this grid, and then we graph it. We graph the altitude at solar noon. We graph the number of daylight hours. And when you do that, you can figure out the tilt of the Earth. You can figure out the latitude that you're at. You can figure out the length of the year, and you can figure out the length of the solar day. And then you can take it one step further. You can go and put a pinhole camera on the roof of your building. And we did this at John Abbott College. And you get this beautiful solography picture of the path of the sun on every clear day from winter solstice to summer solstice. And then you can compare that to one of the archaeoastronomical things like the beautiful Chanquillo the mountain teeth, where you can see the sun rise from June solstice to December solstice and at the equinox and cut up the entire year into equal segments. And this is an incredible thing for them to recognize that what they're doing here with timeanddate.com and with a pinhole camera and photographic paper was done by the ancients. And they had their entire architecture set up in such a way that they had this observation naturally. And then you can do something like doing the Eratosthenes Experiment, where we actually are one of the few schools in Canada that participate in the global Eratosthenes Experiment. And so I get the students to go out on the equinox. They're going out in about a week and a half. They go out every September and they measure the size of the shadow. And they can do it very simply. They can just take something like a plunger and just stick it on the ground and just measure the size of the shadow. And from that, they can determine the relative circumference of the Earth by figuring out the distance from where they are to the equator, because at the equator on the equinox, there's no shadow. And so they can mimic Eratosthenes' experiment. But the other thing that I really want them to understand is these beautiful pictures that you see in papers. This is one by Adrian Bradley at Okie-Tex, a beautiful dark sky spot. This is Francois Canel in in rural Quebec, outside of Montreal area. You get these amazing pictures of Orion, of the winter hexagon. But we suffer in Montreal from this impact of light pollution, and I want them to recognize just how bad of an impact that is. So I have them do the globe at night activity, where they go out during a week and a half span, and they look for a specific constellation that's part of that specific campaign for Globe at Night. And they have to determine whether they can only see the brightest of the stars, the second brightest and the brightest of the stars, a lot of the stars, or all of the stars that could be possibly visible to your eye. And that tells them just how bad the light pollution is in the area of the city where they live. And then we report that back to Globe at Night to be part of this push to try to bring back the dark skies. When we do that, it's kind of interesting to note that we have to be very careful in the wintertime because it's always either cloudy or really, really, really cold. And so when I tried to do this in January, the 5 clear nights that we had averaged a temperature of minus 31 degrees Celsius. Now in Orange County, you may not know what minus 31 degrees Celsius feels like. It's really, really, really cold, but it's something that we have dealt with before, but I'm not going to make my students go out in weather like that. So I extended it and I made it the next month, and then I made it the next month. And I gave them more time to do it. What was astonishing to me was the number of students who said, you know what, it's minus 35, but I'm still going out. And they started taking pictures of Orion and saying, look, sir, look at what I caught. Look at this beautiful picture because I went to a park nearby instead of staying near home. And then they do that lab where they get to see what that Orion Nebula really looks like. And they go back to these pictures and they go, oh, look, I had a little bit of fuzziness around there. Is that what I was really seeing? And the connection starts to be made. And that's really the key to getting them to look up, is to make those connections. And then those connections never stop. We had a lunar eclipse on November 19th, and I was out and I was trying to take pictures of it. And here it is with the penumbral shadow, and then the shadow really starts, right? That umbra starts to cut up parts of the moon, and I was so happy I was going to get to see it, and then the clouds came. And when the clouds came, I had lost the ability to see it. And I was sharing my images live with the Virtual Telescope Project in Italy. So I was really looking forward to seeing my picture of the moon eclipse showing up on that. And I was like, you know, that's okay. I'm just going to support them. And I went into the chat and I was part of the whole live feed. And I was talking to Jim. And all of a sudden, I got a message from a student saying, I'm still out here and it looks like the clouds are breaking. Can I send you my pictures? And I said, sure. And Vanessa got a beautiful picture of that 97% lunar eclipse. And that not only ended up getting shared to 85,000 people live in the middle of the night on November 19th, it also was featured on the local news that next night. And this, for the students, is the type of experience that will stay with them because they stayed out, they were persistent, they were patient, they understood that this is what astronomy is all about. I just want to go through a couple more things before I stop, because this part here, I think, is really going to stick with people, and then I'll stop after this. But Aaron was one of the students in the first term that I ever taught astronomy. And Aaron has actually stayed a friend. He's now doing his master's in urban architecture, and he still comes by every now and then to borrow a telescope and take out with him camping or with friends. But the mention from him is, when he was younger, he would watch TV, he would read books, he would watch documentaries, he would learn about space. But the idea of getting a community that includes him, that his passion is felt and shared and reciprocated, was just something that he could not get past. And he was learning about Galileo in another class in social sciences. And with the outreach activities with the RASC, going out and physically seeing the Galilean moons just ingrained it forever. And when we talk about Galileo's observations, I mean, Galileo had cloudy nights too. Look at January 9th there, where he didn't see anything. But when we go out to see that in our telescope, what we see is this. We see a ball of light and a couple of little points. If we try to see the features of Jupiter more clearly, unfortunately, we end up losing the moons often. And so it takes a little bit of skill to learn how to see it more. But what the students love is actually just following these moons. And so we have a digital simulation in the lab where they can watch the moons and they can figure out from the radius and the orbit, they can show Kepler's third law. They can even figure out a mass for Jupiter, and they love that. And then they can go back and they can try to plot out where the moons are and figure out which moons you'll see at what time of what night when you go out. And then they can go out with the right equipment to try to capture the moons and the stripes on the planet at the same time. Now, Jupiter is an area of interest for everybody. I loved Jupiter as a kid. It was my favorite thing, all about space. It was the only thing I would really talk about. So I thought it was only just to teach my students that they can be part of Juno research. They can be part of understanding Jupiter. And more than that, they can actually see those pretty pictures of the clouds and the storms themselves. And so I teach them about JunoCam. And I show them the different types of images you get from JunoCam as it passes by on one of its perijoves. And then they pull up these beautiful red, green, and blue pictures. And I tell them not to touch them yet. And the reason I tell them not to touch them, if you've never done JunoCam, JunoCam has a very yellow-brown bias to the camera. So if you take the RBG and you just process them the way you would normally do an RGB set of images and you stack them, you're going to get a pretty yellowy picture. But Juno, the scientists who put together this public camera system on JPL, they actually set up a color map projected image that combines the three in the right ratio to give you something closer to a true color for Jupiter. And so I give them a perijove and I tell them, now go ahead and using GIMP, because it's free software, go ahead, process this data. Let's see what you can get out of Jupiter. And they love it. They love working through it. And then this term, I decided to do something different. I gave them all the exact same workflow to get this image here if they wanted to. And once they got this image of the entire area of Jupiter in the southern temperate region, visible to Juno during perijove 35, I told them to go back to the map projected, pick a tiny square and focus on it and draw out a detail. And then I made a collage for it and I gave it to them as a nice going away before March break, before their study week. So they all got a little photo of this to take home with them, a collage of Jupiter that they themselves made. And you can see how many of them were interested in the same storm, how many of them were interested in other things. And that starts to take us into other solar system probes, which is one of the projects that I offer to them. They can do the Cassini mission data. They can look at New Horizons. They can even go to the Parker Space Probe or the Solar Dynamics Observatory, and they can dive more into whatever solar system object they find the most interesting. I'm going to skip ahead a little bit here. Sorry, there's a lot of fun stuff here, but I just want to skip ahead. When we do all of this with the students, one of the big things that comes out of this is the students gain confidence in their ability to talk about space, to share the knowledge that they gain from class, from their readings, from their own independent research. And so they get involved in these public presentations. They step up to give public presentations. No matter what level they're at, no matter whether they're continuing on in physics and astronomy or whether it's just an area of interest, a lot of them like the idea of being able to share a little bit of what they gain. A couple of months ago, we celebrated Roberta Bondar's 30th anniversary of becoming the first Canadian woman and the first neurologist in space. We did it with 2 presentations because she herself was part of a foundation event, so she couldn't be part of our event, even though we were with her alma mater, Guelph. But we ended up with one student, a former student of mine, doing a talk summarizing Dr. Bondar's work, and another student, Catherine, who you met earlier. Well, I told you she didn't want anything to do with physics and didn't want anything to do with astronomy, right? So she went into dietetics and she's a nutritionist. And as a nutritionist, she got hired by the Canadian Space Agency for a 1-year project to help with the Deep Sky Food Challenge. So she was working on a project to evaluate other projects that were aiming to grow food in space that would be efficient, nutritionally efficient in terms of the space it would take and in terms of the amount of waste that it might produce, and that it would be something that could also be done in potential colonies on the moon or on Mars. And so she found her niche to be able to participate a little bit in space science while being true to the side of her that she loved, which is biology and chemistry. And that was one of the most amazing things for me to see is here's one student who's gone on in astrophysics and one student who wanted nothing to do with physics. And together they gave us a total view of the way in which we can look at the Canadian contributions to astronauts in space exploration. So with that, I'll stop there. I had a blast sharing that with you, and I'm open to taking any questions.
Fascinating, fascinating. Very much enjoyed all that you're doing. And I think I graduated a decade soon. I would have loved to be in college when you were teaching these. So the floor is open. Please go ahead and send your questions in the Q&A. And let me start by a few technical ones that I'm the most interested in. So for exoplanet study, are you using AstroImage J for getting those?
Exactly. So AstroImage J is one of the easiest ones to use. And it's free software, which is great for the students who take more than 30 days to do their project, which is, most of them. But what's really great about the way in which the RASC approached this project. So the Royal Astronomical Society of Canada, when we pitched to purchase this remote telescope, one of the big questions was, how is this going to get used? And they thought that it would just be, people buying time to take pretty pictures or things like that. But when we came up with this wonderful outreach component, we developed two sets of programs. One is a very basic program where the image files are taken, they're they're calibrated, they're rotated, they're aligned, everything is done, and all the students need to do is pick out the couple of stars that they're looking at and then run the photometry curve and then try to understand what the photometry curve is showing them. What my students do is the advanced program where they have to walk through every single step from choosing the exoplanet to being there at night while it's being programmed, the telescope. So this past Wednesday, we were up until 11 o'clock at night programming the telescope, and we were about to get it to start, and there was a cable error. Now, the telescope's in California. We are in Montreal and Toronto for our operator. We can't access the telescope, so the night's run was a wash. We put the telescope back to sleep. We'll do it another Wednesday. But those types of realities is what my students need to see. And then once they get the data, Jenna Hines, our previous outreach coordinator, put together a set of videos that walk the students through a simple set of data analysis, and they follow that same procedure with their set of data analysis. And then there's always a few things that they have to figure out for themselves. But the basic program with the video tutorials is ready for them to watch. And so the advanced program becomes much more accessible to them. And these resources that she put together are just top notch. They're like, it's basically just, screen recording as she goes through, right? It's something that is doable, but the forethought to put that together before students run into problems, oh man, it saved so much time for me. There were so many hurdles that we didn't have as a result.
Are those tutorials available publicly, or is it on a private
I'm sure
channel?
I can share them with you. I'll reach out to them.
Okay, great. And so you using the facility that you have got in California, does that provide the FITS header with the Orion deck? So if I understand, AstroImage J can do some of this stuff automatically if the image has all those information.
It can if it has all that information, but that's one of the things that we tell the students not to rely on. We use that for our outreach sessions to automate some of the stacking so that they can see stuff in real time. So when we have high school students and we want to show them a faint galaxy, we can stack it a little bit in real time and they can see it while they're on the telescope with us. And that works really well, especially for some of the schools where we record a session and then we play it for them with the person who recorded it there during the playback to answer questions. That works beautifully. We don't want the advanced students to take advantage of that right now, but it is something that we want to debug, because one of the things we're hoping to do, and I want to tie this into Kim's comment about the love of music, is we want to be able to do photometry curves of variable stars. In order to do that, you need very precise photometry curves with much less of that scatter. And so that's where we're hoping that the RA deck suite can be clean enough to give us that automatic alignment where we can get good photometry curves.
Great. And you also mentioned, in addition to building some or refurbishing some telescopes, you built a radio telescope. How did that go?
So we built one of the double pole ones. So it's basically just taking wire between large frames and then running it into a patched amplifier. and then a receiver that goes into a laptop. And then we use the Radio Jove interface to do it. And I've only had one group who wanted to try it, and they absolutely adored it. The problem was, it was a fall semester. So by the time they had everything built and ready to go, it was November in Montreal. November in Montreal, the sun doesn't rise very high. And so I can tell you, we managed to get some very interesting chatter on the facilities radio from our radio telescope, but we didn't get any solar or Jupiter or galaxy signals. However, they asked me to store everything the way they packed it up. And so I have stored it the way they packed it up. And one of them is currently in electrical engineering co-op. And she's finally in an off term this summer where she's on campus for classes. And so she said that if she's able to, she'd like to come and set it up again and see if it still works. So I'm hoping to one day get real radio signals on our campus that have nothing to do with so-and-so being late for the wrong reason.
Can I jump in for a second?
Sure.
I work in education, and I'm glad to see an excellent implementation of student-centered learning / Vygotsky.
Thank you. Thank you. This is the thing, is the student-centered approach. And I actually combine it with just-in-time teaching. And that's the part that I was kind of alluding to, where the students choose the resources. They even write quizzes for each other. This is what's so cool. I have 4 students every week. On the Tuesday before the week, they submit the resource they think the whole class should watch and the quiz they think the class should do. I take the best of the resources that's the most recent. I look at the quiz questions and pick any that could overlap with that video, so they don't have to do any extra reading or any extra resource. And I program in the quiz into a Lon Kappa interface so that they all have access to it for free. And then on Thursday at the end of class, I activate the resource and the quiz due Tuesday before class. So they have 4 days to watch the resource chosen by one student and answer a quiz chosen by the other 3 students together. And that brings them into class all having a certain baseline that I then start from.
If I can make one more observation, a lot of science education is either a kind of harassment or an elimination process where we just get the absolutely smartest people involved. And I think you're doing a very good job, like in a way like teaching piano. If a student doesn't learn to like piano and music, they'll never, except very few of them will ever succeed at playing the piano or the harp. And the same with astronomy, they've got to enjoy it. And so it's got to be positive and enticing rather than off-putting. And I saw John Hoot come up with a question. He's got an interferometer you may want to look at.
I was just seeing that. I'm just typing my email address into the chat for.
Okay. John's our resident genius.
Oh, fantastic.
He helped rebuild the SNO telescope up in Mount Wilson.
Oh, wow.
He's quite.
Wow.
So, well, you know what an LX200 is?
Yep.
It came out of his brain.
Oof.
Yeah. I'm sorry, John. I'm bragging about you, but I'm impressed. So
my jaws. We have to get him onto the Global Star Party one night to chat about it. Like, that would be great.
Him. Sure, ask him.
Definitely.
Okay.
So one of the things that I wanted to mention with what you're saying is, this is the key to having the course connected to the RASC Montreal Center. The majority of our members are not astronomers. They never took an astronomy course in their life. Some of them took a few of the introductory type courses like what you're offering in April. Most of them, they've learned it as practice as they go. And so they love hearing from the students a little bit about the actual science of what they're looking at. Some of them are really well versed in the science, more so than me. It's amazing what some of them know compared to the bits that I know from my approach to the course. But what's incredible for them to see is that the person who works in a factory, the person who works at a retail convenience store, the person who is an engineer for a living in machinery and design, the person who's a pharmacist, all of them at night under the stars are collegial. They're all friends. They're all at the same level. They're all sharing their expertise, and everybody's scopes are open. And when I came, one of the things that was being discussed was the fact that what's the future for the club, because the club was becoming very quiet and there didn't seem to be a lot of vibrancy and there were not a lot of youth members. And by the time our 100-year anniversary hit 2 years in to our partnership, we were up over 170 members, which is a gain of 50. And of those 170, our events would have 80 members and then 50 people from the public. And so you would have an incredible turnout to a lot of our events. And our outings would always have parking completely full. Like there's nowhere for anybody to go. And some people would even just like park over on the street and bring all their equipment slowly, because there was this vibe again where everybody wants to talk astronomy, everybody wants to share their view. And during COVID times, we were one of the first clubs here in Canada to switch over to Zoom. And since March 13th, 2020, every week we have 2 Zoom meetings, plus public events once a month. Plus now I do the outreach twice a week on different formats. And on top of all of that, we also attend Zoom meetings from other centers and have those people come to our Zoom meetings, because this is the chance for us to actually share and chat and be with other people. And because everybody's stuck at home, we got to share what we see in our backyard with each other. And that vibrancy of still continuing to meet twice a week and, 25 people sitting there on Zoom, sometimes even with the video off because you just can't deal with the screen anymore, but still wanting to hear and chat with each other. That's the camaraderie that sticks with you. That's why like these types of clubs are so important, because you've got that shared experience under the eyepiece. And when the students see that that sort of stuff exists, they don't know that that's there. The last time they saw something like that was Girl Guides and Scouts.
Yeah. Good. Well, we've done that. We've reached out quite a lot too.
I saw your outreach material, like your outreach presentations. It seems really cool, some of the stuff that you're doing.
Yeah. Yeah. We've also had people come, since we've been on Zoom, we've been able to have speakers like yourself from all over the world and that's been a whole new perspective for the club. Our good and bad part is we can just call up JPL and get a speaker for next week. That's no problem. It's not very far away. Never mind. The school's on Chapman Avenue, and there's 2 of those in the area, so sometimes our speakers get lost. But anyway, that's the bad thing, is that speakers are so easy to find, good ones, and even in the club. But now with the COVID thing, we've been reaching out internationally, and that's been very, very exciting. And we hope we've got a way figured out to be able to do that when we finally meet on ground and have most of our people in the audience, and then still be on Zoom and YouTube and have interactive meetings. But we're fond of saying the nice thing about being an astronomer is it doesn't matter what you wear. There are no name brand clothes, for instance, for astronomy, where it's all black. And so there isn't that kind of competition, social competition, although there is some competition about the light gathering ability of your telescope. And we've had some of those.
Yes, no, definitely. And I'm always envious of the people who have managed to build their own telescope from scratch. There's some incredible designs out there. And that's one of the things that I loved about Stellafane when I managed to go there a couple of years, is seeing what people build by hand and seeing the process and the workshops. I wish I had that skill. I personally, I hate to say this type of stuff, because when my students say it, I'm like, no, don't limit yourself. But I've had, many years of experience trying to build stuff and knowing that I always miss out a little bit on this end or that. But locally, we're lucky. We have Norman Fulham just off island. If you know Fulham Optics, that's just some of the most incredible mirrors that exist. And he had no training in astronomy. He learned all of that himself. All of his machinery, all of his apparatus is hand built. And so he is one of those who when he has time, he'll share his knowledge with anyone and everyone. So you're saying JPL being right there, take advantage of it. That's just
of course we do. We're doing a series on adventures in astronomy in the next year, and we're interviewing different people about what their journey is in astronomy. And right away, it's obvious everybody's is quite different, although it can be categorized. Like they're the people that are builders. They've got to build everything they own. They're the guys that are like to do the electronics. Guys and women, and then some people like myself, I'm an observational astronomer. Don't tie me down with having to build anything. I want to take it out to the desert and I want to see as much stuff as I can for as long as I can. But everybody has their own approach, and yet we all gather together around an eyepiece.
Yeah, No, I mean, so you have JPL there. One of the things we're lucky with here in Montreal is we have not only the MDA company, we also have the Canadian Space Agency nearby. We have McGill Research Institute and Space Institute. Then we have the Institute for Research on Exoplanets, which is the group that did the NIRISS camera on James Webb. And so we have had access to the ground level of James Webb for the last, well, the 7 years that I've been part of all of this. We've been hearing about it from day one. And so the fact that everything has gone off so flawlessly for James Webb so far, knock on wood, I have just been telling the students that you don't know the stress that these people have been going through with the design of equipment and then sending it out there and hoping it all unfurls properly. But that side of space exploration and space telescopes connects to what we do on the ground. And that's what I want them to see is the collimating of those 18 hexagonal mirrors, and collimating your mirror on your Dob is connected, and you're trying to do the same type of thing. And so when they start to see those connections, it starts to broaden their horizon of what they can do with this knowledge.
Great. So we have a question about EAA. Have you done any outreach with EAA or taught students about EAA techniques?
So with EAA, one of the big things that we've tried to be doing during COVID was here's how I would have meant to. Before COVID started, I had put in for an astrophotography project at my college. And as part of that, I wanted to get an EV scope. And specifically, I wanted an EV scope because I wanted a way to stack where the students could access what I'm doing and potentially take over easily. I have some disabilities, and so I knew I would have trouble carrying out large equipment, whereas the EV scope comes in a knapsack. I thought this would be an easier thing for me to do. When COVID started, everything got delayed, and then the shipment got delayed. And so I managed to get it in December of 2020 when, it's minus 30 degrees here. So my first light was April 2021. And since first light, I've only been able to use the EV scope 4 times. But the very first time I used it, I just set up a Zoom and I had students join in and I had alumni students join in. And we did a couple of objects around the Big Dipper. We did M1, M81, M82, Owl Nebula, and the Whirlpool. And it was just fascinating for them because while it's stacking, you talk about it and you tell them all of the things of what they're going to see and what's popping out. And you share with them a little bit of the history of the observation, how the Leviathan telescope was used. And you tell them some of this as they're seeing it. Now, what I'd like to be able to do is do that in real time as well with the LCO telescopes or with the school's telescopes and just access the archive data if I can't access real time on those telescopes. I have yet to actually get time to try to figure that out. So what I do instead is for EAA, I use the local astronomers who have screens already that they use with their telescopes, and I enlist them to come out. So we did the first semi-in-person event last summer in between the COVID waves, and we did it all by EAA. Not a single person went up to your eyepiece. It was either the XYZ with your cell phone, or it was a little Lilliput screen with an HDMI out from your DSLR camera at prime focus, or it was a tablet or a laptop live stacking using the ASI Air. And it worked really well for what it was. What we missed was the ability to teach people how to use the telescope or the ability for multiple people to spend time with you one-on-one, because they look at something on a screen and they walk away. They don't tend to ask as much when they're looking at a screen than they do when they're looking through the eyepiece, and then they look at you and they're like, is that really what I'm seeing? Those moments are what we still have to capture with EAA. So I've been lucky that there's a few outreach colleagues that do it really well. So there's Astronomy by the Bay, which is Chris Kerwin, Paul Owen, and Mike. They're in New Brunswick, which is just north of Maine. And they do a Sunday night astronomy show. They do live feeds on Facebook and on YouTube, and they share what they do at the eyepiece with a screen. And they've been doing that since before COVID. They set up and they have a little screen there showing whatever they're seeing through an electronic meet eyepiece or just through a cell phone camera or a cell phone and an HDMI cable. And so just 2 weeks ago, I hosted a workshop discussion with outreach people from across Canada, from the different RASC centers. And what we're trying to put together right now is not a best practices, but a shared practices. A set of, this is what we can do for EAA and outreach, because now that things are opening up, we want to try to do it safely. So there's one gentleman, Tim Doucette in Nova Scotia, who 3D printed a set of eyepiece cover holders that you put plastic in, and you put them over the eyepiece, and he put that on Thingiverse. So it's available to anyone. And his idea is when a family pulls up or when a car pulls up, you hand them one of these and you say, pass this to me at the end of the night. Any telescope you go to, just put this over before you look. And that way you can go back to that sharing eyepieces without actually sharing your eyepiece. I love it. I think it's fantastic. I haven't tried it myself, but it's the way to not do EAA, but still do outreach safely, because a lot of our astronomers do not want to do EAA. They hesitate to embrace it. And I understand that. And we don't want to lose them as outreach volunteers. We also don't want them to miss that moment. Because this is the thing about outreach that people don't understand. Outreach is as much for you as it is for the public. You get so much out of that moment. It's the same as teaching. Like, yeah, it's exhausting and everything, but those moments of light bulbs sparked and seeing people's eyes pop open, that's why you do it.
But absolutely, I have been able to see things that I would have never been able to see if I were planning. For example, while I'm doing outreach, I saw things passing across that I could have not managed to see that if I planned for it. And you spoke about the EV scopes. So how do they hold in minus 30 degrees?
They don't.
Okay.
They don't. I can't. Honestly, the coldest that I tried to use them was -8, and there was some humidity, and the whole thing froze up. And the biggest problem in the cold, so there's two problems. One is just that everything ices up, and you can get around that with eyepiece heaters and this and that. But your battery drains so fast in the cold. And that's something that we struggle with here in Canada and in northern US. When we talk to the Michigan Club, part of the reason why I joined the Michigan Club for the Astronomical League access is because they have a shared experience with the people right across the lake in Sudbury, because they have almost the same climate. There's very little difference. I grew up in southern Pennsylvania, and the climate isn't that different between there and southern Quebec, except that our cold gets a little colder and our fluctuations are a little bit wilder. We still see about the same amount of snow overall. Ours just stays for longer.
Okay, great. And you mentioned you do have a 14-inch, if I'm not mistaken, on campus?
At the McGill campus, yeah.
And you mentioned about, are you using that Tom Fields R-Spec thing on that scope?
Not yet, not yet. When I use the R-Spec, I tend to use it with my 8-inch Nexstar. I find that it's a nice amount of magnification. It's also a nice amount of light gathering where I'm not blowing out any of the spectra, and I can see second order for most of the brighter stars fairly nicely. What I want to try to do is I want to try to connect the R-Spec with a better capture mechanism, because one of the things that's difficult is just using a smartphone camera. You can't follow a variable star. And one of the most wonderful parts of R-Spec is not only you can do spectra of stars with individual images, you can do live spectra of volatile stars. So you can see their emission lines change in real time when a Cepheid variable star is about to flip over from helium-1+ to helium-2+ ionization. You can actually see the Balmer line switch because you can see the temperature fluctuate. And that type of an observation, if I can get that into the introductory, actually, that would be more suited towards the astrophysics course. But if I can record that, that's the sort of thing that you normally would be looking at, those professional spectrographs that, are so cooled and, down to like 3 degrees Kelvin, some of them, and you're trying to do those. But the thing that sticks with me, and this is what I tell people when they say, but really, is this real science? When I went to Mont Observatory, which is one of the research observatories here in Canada, it's in the eastern townships of Quebec. They have a huge, big research telescope, 26-inch, and they have one of the best spectrographs. They're the ones who were originally doing a lot of the test confirmation, the Kepler confirmations actually early on. A lot of my students who go on to do research projects at university level, they go to use Mont. They have star parties every summer. And the last time they had a star party, I went there and they invite amateur astronomers to set up public telescopes anywhere on their whole area. So I set up outside of the research observatory. It was windy, it was chaotic, it was cold, but I decided I wanted to show the spectra of Vega. So I put in the filter, I put it up on Vega, and I literally hugged the telescope to hold it there because it was so windy. And the public would come up and they'd see it and I'd explain to them what they're seeing. And then all of a sudden, the research astronomers came running out going, is it true that you have an actual spectra in your telescope? And I said, yeah. It's like, can we see? Because all we ever get are grids of numbers. We never actually get to see the spectra. And so they're like, can you move it to this star? Can you move it to that? And I just gave them the control and I said, go for it. And they spent like 40 minutes and took turns going in to run the research side so that the other person could choose targets and say, that's what it looks like, taking pictures and then moving on. Because research, it's very easy to get lost in the data and forget what you're looking at. Outreach allows you to always remember what you're looking at. And that stuck with me for the usefulness of RSpec.
Wonderful, wonderful. That was great. Thank you very much. So I believe I've covered all the questions. Thank you very much again. And I hope we could start actually a partnership. There's a lot more that we could share and learn from you. Thank you very much, Karim. And I would like to thank all the attendees for staying with us this long and all the panelists. Do you have any final remarks before I close out the meeting? Okay, thank you.
It's been wonderful to visit.
Great. So please check the calendar on our website for all our upcoming events at ocastronomers.org. Thank you for joining us, and we wish you all great times ahead. Bye-bye now.